Right, I'm going to work through these molar gas calculations so you can make sure you're familiar with these. Key thing is that 1 mole of a gas will occupy the same volume. Doesn't matter what gas it is, doesn't matter what size the gas molecule is, but 1 mole of that substance, 1 mole of that gas will occupy the same volume regardless. Now at GCSE you're only expected to know what the volume is at standard temperature or room temperature and pressure, which is 24 decimeters cubed. You need to remember as well that 24 decimeters cubed is the same as 24,000 centimeters cubed, because 1 decimeter cubed is equal to 1,000 centimeters cubed. Be mindful that you may see questions where they expect you to work between those 2 units. You'll see here 1 mole of helium is 4 grams. It occupies the same volume as 1 mole of ammonia. It says 15 there, it should really be 17. And 1 mole of oxygen here is 32 grams. You notice that 1 mole of each of these gases occupy the same volume. So the equation that you need to make sure that you can remember is this one here. The volume of the gas is equal to the number of moles of that gas times the molar gas volume. An easy way to remember that is V equals N times 24. So what is the volume of any gas at 1 atmosphere and room temperature of 20 degrees? It is 24 decimeters cubed. Okay, moving on. Worked through these ones already, so I'll just go through them quickly. What's the volume in centimeters cubed of 0.04 moles of neon gas? The volume is the number of moles times 24. If our volume is 0.04 moles and if the number of moles of gas we have is 0.04 and 1 mole occupies 24, that gives us 0.96 decimeters cubed, which is 960 centimeters cubed, because the question's asking us to give their answer in centimeters cubed, so just be mindful of that. How many decimeters cubed of phosgene gas would there be in 300 centimeters? We're just dividing by 1,000, so it's 0.3 decimeters cubed. How many moles of chlorine gas occupy a volume of 9.6 decimeters cubed? So the number of moles will be equal to the volume divided by 24. So 9.6 divided by 24 gives us 0.4 moles of the chlorine gas. And then a molar volume of natural gas is 24,000 centimeters cubed. How many moles of it would occupy a volume of 4,800 centimeters cubed? So 4,800 divided by 24,000 gives us 0.24 moles. Those were just really straightforward introductory questions. It'll get a bit more interesting as we progress. How many moles of water are there in 300 decimeters cubed of the vapor steam room? So it's 300 decimeters cubed. 1 mole will contain 24, so the 300 divided by the 24 gives us 12.5. Dry ice is a form of carbon dioxide. It can be used to produce the appearance of bubbling solutions and white mists as it warms up its sublimes. 4.4 grams of this solid are turned into a gas. What volume would it occupy in decimeters cubed? So the number of moles is equal to the mass divided by the MR. We have a mass of 4.4 grams of carbon dioxide and the MR is 44. So that's 0.1 of a mole. Of the carbon dioxide. So the volume is N times 24. So the volume will be 0.1 times the 24. So our volume will be 2.4. decimeters cubed. Gas bottles in shops contain 5.8 kilograms of butane gas. How many moles are in a steel bottle, and what volume would it occupy if it were released? We've been given the MR of butane. We've also been told that we have 5.8 kilograms of butane gas. That's 5,800 grams. Because when we're working in moles, we always need to be remembered to be working in grams. So the number of moles is the mass or the MR. So we have 5,800 grams divided by the MR of 58. So that's 100 moles. What volume would it occupy if it were released then? So volume is the number of moles times 24. So the volume will be the 100 moles times the 24 decimeters cubed. So the volume would be 2,400 decimeters cubed. And that's that one. Water can be decomposed during electrolysis to form hydrogen and oxygen. So we have our equation here. If 1.2 decimeters cubed of oxygen was produced in this reaction, what mass of water must have been used? So this is our kind of theoretical yield kind of question, combined with our molar volumes. So we have 2 moles of water makes 1 mole of oxygen. So if we have 1.2 moles, number of moles of oxygen, number of moles is the volume, which in this case is 1.2 decimeters cubed, divided by the volume of 1 mole, which is 24. So we have 1.2 divided by 24. So we have 0.05 moles of oxygen. Now it is a 1 to 2 ratio. So if we have 1 mole of oxygen, that means we would have needed 2 moles of oxygen, 2 moles of water. So times on that by 2 would be 0.1 of water. So that gives us the 2 to 1 ratio, the 0.1 to 0.05. That's the 2 to 1 ratio. So if we then look at this in the context of water, we have 0.1 moles of water. The mass is equal to the number of moles times the MR. So the mass will be the 0.1 moles times the MR of water, which is 18. So it's 1.8 grams. Moving on. So in this question, there are a few parts to this to kind of break it down to make it a bit sort of easier but we'll just go straight to what the main thing is. I'll talk through parts A to D. How many moles of carbon dioxide are formed from 1 mole of carbon? So with part A, this is just getting you to think about the mole ratio. 1 mole makes 1 mole. Okay, so it's a 1-to-1 ratio. What volume of carbon dioxide is formed from 1 mole of carbon? So it's 1 mole of carbon dioxide will make 1 mole. 1 mole of carbon dioxide will be formed from 1 mole of carbon. So again, it's just basically another way of thinking about part A. See how many moles of carbon are there in 12 grams of carbon. So the number of moles is the mass over the MR. So we have 12 grams of carbon. If you look at your periodic table, the AR for carbon is 12, so it's 1 mole. 1 mole of carbon is 12 grams. So it is a 1-to-1 ratio. That means that 1 mole of carbon dioxide will be produced from this 1 mole of carbon. And the question is then, what volume of gas will that be? So 1 mole will make 1 mole of CO2. Well, if it's 1 mole, it will occupy 24 decimeters cubed at standard temperature and pressure. Okay, so this is a really straightforward one to get started in the increasing challenge. What volume of hydrogen at room temperature and pressure is produced when 12 grams of magnesium reacts with an excess of acid? So here's our magnesium, and it's reacting with the excess of acid, and here's the hydrogen that we expect to get. What you need to notice is that 1 mole makes 1 mole. It's a 1-to-1 ratio. Now we've been given here that it is, we have 12 grams of magnesium. So the number of moles is the mass over the MR. So we have 12 divided by 24, which gives us 0.5 moles of magnesium. As we said, it is a 1-to-1 ratio, which means we will get, if it's 1 mole, it'll make 1 mole. If it's 0.5, we'll get 0.5 moles. So in this instance, we will get half a mole of hydrogen gas. Okay, so what volume will that occupy? So this is part D. The volume will be the number of moles times 24. So the volume is 0.5 times 24, which means the volume of hydrogen gas produced will be 12 decimeters cubed. And moving on. What volume of hydrogen at room temperature and pressure is produced when 5.5 grams of zinc reacts with an excess of hydrochloric acid? And zinc, actually, if I remember, that's a mistake. That should be 6.5 grams of zinc. So how many moles of hydrogen are produced from 1 mole of zinc? 1 mole of zinc makes 1 mole of hydrogen, so it's a 1-to-1 ratio. So part B, what's the volume of this number of moles of hydrogen? Well, if it was 1 mole of hydrogen, it would be 24 centimeters cubed, decimeters cubed, sorry. Part C, how many moles are present in 6.5 grams of zinc? Number of moles is the mass over the MR, or AR. So in this instance, it'll be 6.5 hydrogen will be produced from this volume of moles. So this is part D. It is a 1-to-1 relationship or ratio. 1 mole of zinc would make 1 mole of hydrogen, therefore 0.1 moles of zinc will make 0.1 moles of hydrogen. So the volume will be the number of moles times 24. So the volume is 0.1 times 24. Therefore the volume will be 2.4 decimeters cubed. And next one. What is the volume of carbon dioxide produced by heating 10 grams of calcium carbonate? You notice there's our calcium carbonate, and here's the carbon dioxide gas being produced. In part A, it is a 1-to-1 relationship. It's 1 mole makes 1 mole. What's the volume of this number of moles of carbon dioxide? 1 mole of carbon dioxide will be 24 decimeters cubed. How many moles are there in 10 grams of calcium carbonate? So the number of moles is the mass over the MR. The MR of calcium carbonate is 100. So that's 10 over 100, which is 0.1 moles. So because it's a 1-to-1 relationship or a 1-to-1 ratio, that means we will get 0.1 moles of carbon dioxide produced. Therefore, the volume will be the number of moles times 24, so the volume will be 0.1 times 24, so the volume will be 2.4 decimeters cubed. Next one. Calculate the volume of oxygen at room temperature and pressure needed for the complete combustion of 125 centimeters cubed of methane. What volume of carbon dioxide is produced? Here's the methane, here's the oxygen, and here's the carbon dioxide. So part A, how many moles of oxygen react with 1 mole of methane? So it's 2-to-1. 2 moles of oxygen are required to react with 1 mole of methane. So 2 moles O2 to 1 mole methane. So how many volumes of oxygen react with 1 volume of methane? So basically it's going to be a 2. If we have 125 centimeters cubed of methane, because it's a 1-to-2 ratio, we're going to have double the amount of oxygen reacting with this volume of methane. So we will get 250 centimeters cubed of oxygen reacting in this context. So that's kind of what we're getting at in part C as well. So that's part C. Okay, so how many moles of carbon dioxide are formed by the combustion of 1 mole of methane? So part D, that's methane CH4 makes 1 mole of carbon dioxide. So this is a 1-to-1 ratio. How many volumes of carbon dioxide are formed from 1 volume of methane? Well, it's 1-to-1. What volume of carbon dioxide is formed from 125 centimeters cubed of methane? So it's a 1-to-1 relationship. So if we have 125 centimeters cubed, we will get 125 centimeters cubed. Because the point of this question is that you need to get the idea that although these are different masses of gases, the molar relationships are the same, the ratio is the same. It's 1 mole, or in this context 125 centimeters cubed. It's occupying the same volume of another gas at the same temperature and pressure, and that's the idea behind this. Question 6. The complete combustion of carbon dioxide. The complete combustion of carbon and oxygen yields carbon dioxide. Calculate the volume of oxygen at room temperature and pressure that would react with 10 grams of carbon, and the volume of carbon dioxide produced. carbon plus oxygen makes carbon dioxide. If we have 10 grams of carbon, the number of moles is the mass over the MR. So 10 over 12 will give us 0.83. 0.83 moles. Calculate the volume of oxygen that would react with the 10 grams of carbon. So the relationship here is that it's a 1-to-1 ratio. So if we have 0.83 moles of carbon, then we're going to need 0.83 moles of oxygen. So what volume would that be? So the volume is the number of moles times 24. So the volume would be 0.83 times 24. So it's given us 19.92 decimeters cubed. And then for the volume of carbon dioxide formed, so the CO2 formed would be the same. We would get 1 mole of carbon dioxide is produced. 1 mole of carbon dioxide is produced from 1 mole of carbon. So we would also have 0.83 moles of CO2 being formed, so you'd get the same volume of CO2 produced. So this is for oxygen, and for CO2 it would also be 19.92 decimeters cubed. So in the reaction between marble and hydrochloric acid, the equation is here's our marble, a calcium carbonate. It's reacting with 2 moles of the hydrochloric acid to make 1 mole of carbon dioxide. What mass of marble would be needed to give 11 grams of carbon dioxide? So part A, the number of moles, is the mass over the MR. So we have 11 grams of carbon dioxide. That'll be divided by 44 because the MR for carbon dioxide is 44. So we have 0.25 moles of CO2. It is a 1-to-1 relationship. So we would need 0.25 moles calcium carbonate required to make 11 grams of carbon dioxide. So the mass of that then would be the number of moles times the MR, which would be 0.25 times 100, because the MR of calcium carbonate is 100. And that is 25 grams. So there's our answer. We need 25 grams. But part B is what volume would this gas occupy. So 11 grams of carbon dioxide, as we worked out earlier, is 0.25 moles of carbon dioxide. So the volume will be the number of moles times 24. So 0.25 times 24 gives us 6 decimeters cubed. And there's your answer. Moving on. Zinc reacts with hydrochloric acid to give hydrogen. Zinc plus hydrochloric acid makes zinc chloride and hydrogen gas. What mass of zinc will be needed to give 100 grams of hydrogen? So number of moles is the mass over the MR. The mass is 100 grams of hydrogen divided by 2, because the MR for hydrogen, H2 is 2. So that is 50 moles of hydrogen. Now it's a 1-to-1 relationship here, or 1-to-1 ratio. So 1 mole makes 1 mole. That means we would need 50 moles of zinc, which is an insane amount of zinc, really. So we need 50 moles of zinc. What mass of zinc is that? So the mass is the number of moles times the MR. So the mass will be 50 times the AR of zinc is 65. So that's 3,250 grams of zinc. Okay, that's one expensive experiment. But what volume of gas will this occupy at standard temperature and pressure? So this is part A. Part B, if it is 50 moles of hydrogen, the volume will be 50 times 24. Which gives us 1200 decimeters cubed. And the next one. Lead oxide can be reduced by hydrogen to lead. What volume of hydrogen at room temperature and pressure would be needed to reduce 4.46 grams of lead oxide to lead? What mass of lead will be formed? Okay, number of moles is the mass for the MR. We have 4.46 grams of lead, and got to work out the MR for this one because I don't know what it is. So PB is 207. Oxygen is 16. So 223 divided by 223. Which is 0.02 moles of PbO. Sorry, that should be a big P. Okay, so it is a 1-to-1 ratio here. 1 mole is reduced by 1 mole of hydrogen, so we would need a volume of hydrogen would be 0.2 moles. So the volume would be 0.02 times 24. Which should be 0.48 decimeters cubed. What mass of lead will be formed? So it's another 1-to-1 relationship there between the lead and the lead oxide and the lead. So this is A. So for B, 1-to-1 means we would get 0.02 moles of Pb produced. So that mass is the number of moles times the MR. So we have 0.02 times 207. Which is 4.14 grams. Okay, what volume of oxygen at room temperature and pressure is formed by the decomposition of a solution containing 1.7 grams of hydrogen peroxide? Here's our hydrogen peroxide, here's our oxygen. Hydrogen peroxide, the MR is, there's hydrogen is 1 times 2, so there's 2 of those. Oxygen, there's 2 of those times 16, so 32, so it's 34. So number of moles is the mass over the MR. So we have our 1.7 divided by 34. Which gives us our 0.05 moles. Okay, so now looking at the ratio, it is a 2 to 1 ratio. So basically we've got to divide the 0.05 by 2 to work out the number of moles of oxygen we will get. So that's 0.025 moles of O2. What volume will that be? So the volume will be the number of moles times 24. So the volume will be 0.025 times 24, which gives us 0.6 decimeters cubed. A mixture of hydrogen and oxygen can be exploded to make water. What volume of oxygen is needed to convert 123 centimeters cubed of hydrogen into water? We have a 2 to 1 ratio here. So reasonably straightforward in terms of this. It's 123 centimeters cubed of hydrogen. What volume of oxygen do we need? So because it's a 2 to 1 and because we're working with molar volumes, we can basically divide the 123 by 2. Which gives us 61.5 centimeters cubed. And that's how much oxygen we would need. Propane burns in oxygen to form carbon dioxide and water. And what volume of oxygen at room temperature and pressure is required for the complete combustion of 44 grams of propane? So the MR, 3 times 12 for the carbon. And 8 times 1 for the hydrogen. These are 44. So that is 1 mole of propane. So what volume of oxygen at room temperature and pressure is required for the complete combustion? So 44 grams is 1 mole. And the ratio is 1 to 5. Therefore 5 moles of oxygen will be required. What volume would that be? That would be 5 times 24. It should be 120 decimeters cubed. What volume of carbon dioxide would be produced? Well, this is part A. For part B, for carbon dioxide, it's a 1 to 3 ratio, as in 1 mole of propane makes 3 moles of carbon dioxide. We know we have 1 mole of propane, so it's going to be a volume of 3 moles of carbon dioxide times 24. It is 72 decimeters cubed. Octane burns on oxygen. Here's our octane. What volume of oxygen is needed for the complete combustion of 1 decimeter cubed of octane vapor? What volume of oxygen will be produced? It's a 2 to 25 ratio. So if we take our 1 decimeter cubed of octane, so the 1 divided by 2 but times by 25, gives us 12.5 decimeters cubed of O2. Okay, so what volume of water would be formed? So we do the same thing again. We're looking at the ratios. It is a 2 to 18 ratio. So if we take our 1 divided by 2 but times it by 18, gives us 9 decimeters cubed of H2O. And there's our answers. And we'll do one more. Butane is used as a fuel in camping stoves. 100 centimeters cubed of butane is used in an excess of oxygen. Calculate the volume of oxygen used. So it is a 2 to 13 ratio. So if we have 100 of butane, we divide by 2 and times by 13. We get 650 centimeters cubed. It's going to be the volume of oxygen needed and the volume of carbon dioxide produced. So the ratio this time is 2 to 10. So if we take our 100, divide by 2 times by 10, is 500 centimeters cubed of CO2 produced and oxygen used. So I'm hoping you've kind of got the gist now. There are more of these that go on that become progressively more difficult, getting into sort of out of the territory. If you can do what we've done up to so far, you'll be fine for paper 1. One of the things you could do when you get a chance, if you do, is take a look at the examination practice style questions. There are a few of them that you can contend with at the back. So hope that helps.